Let's welcome Łukasz.
I saw the first presentation from Mateusz, and short disclaimer, my slides are nothing like his. Sorry about that, but I'll show you some code later on. So, hi, my name is Łukasz Reszke. I work at Arkansas. We are working with Rails legacy applications since 2007. And today I will start with something that most likely every one of you knows, which is relational databases, right? Who uses them? Everyone? Okay, cool. And of course, we all know relational databases. We all work with CRUD, right? And today I want to talk about a slightly different way of storing your data. But first, let's admit one thing. Change is a state override. So you have to admit that the information is lost, right? If we change from status A to status B, we only know what it is now. How we get there, do we know that? No, we don't. We just know it is B now. We don't know what it was before, right? So alternative for saving data as snapshots, so this way of persisting information I will refer to as snapshotting the data, is to store the state as a sequence of facts. What are facts? Facts are events, business events that happen within your application. And what I'm describing is, of course, event sourcing, which I want you to remember one thing from this presentation. If you have to only remember one thing, now is the time to focus. Event sourcing is just another persistence technique. It's nothing else but this. It enables you to do more than this, more than just persistence, but in the essence is that is a pattern to help you store the data as sequence of facts. And it uses events to do so. What is an event? An event is this, as I said, fact that represents the state and how your how the data is stored in your system. Events are kept in event store. What is an event store? It's a database for those events. And it's an append-only log, which means that you cannot update it, you cannot delete events from it, and it's immutable, meaning that if the event goes into the event store, it is there. You cannot really modify that. There is no update for events. I'm not sure why my slides are changing. I'll just move this piece away. And another important information is that an event must belong to at least one stream. And I'll show you what it means. So if we had an example from e-commerce, and we have a stream of a basket with ID 111. Let's imagine that we will add some products to this basket, right? Let's add some product. The ID of the product is 1, and we add quantity of 3. Now, if we look at the state of this basket, we can see that, okay, it has 3 products with ID 1. If we add another product with ID 2, quantity 10, we'll have another state, right? So you get the grasp. We build the state. We are not updating it. And once again, we remove a product then with a quantity 1, right? So we still have the product number 1 and the product number 2 in quantity of 9. It was 10, now it's 9. And if we get another basket, 999, then we can go through the same sequence. We add a product, the state is built. And now, if the state is invalidated, the items are removed. So the state is empty, right? We don't have anything in that basket. And stream is this logical representations of what happened to this very specific business thing. In that case, this is a basket, right? So if I would make an analogy to what you know in your CRUD world, this is just an entity, right? Or an active record. But as I said, we store this information differently. It's things that are built upon of the events that are published. So, I'm really not sure what is happening. So we do know how we got into current state, right? So if the business comes to us and asks a business question, which products are mostly abandoned in baskets, right? We know, because we saw which baskets are invalidated and therefore which orders are not finished. So then if they come to us, we can say it's an ID2. So the ones that do not fit into free delivery. Of course, one event can belong to many streams. Yes, so the reason is that, of course, I can make different reports, right? And I want to have these events prepared to create a projection, which is basically just a left fold. So I'm reading all the events from that stream, I'm building the state as I did on these very sticky notes, and then I can answer, okay, my current state is this and that. So basically, the way we work with the events in Event Store is that we load the state, so we load all the events from the stream, we build the state, and then we make some decision, and then once we do that, we publish an event with a new state. And therefore, we keep building on with those events. And as I said, one event can belong to at least one stream, but it can also belong to many streams. So consider the following example. Very same events from the basket, right? Those are the same that you saw on the previous slides. And now, if we would like to build a stream of an order, so what were the orders at 1st of July? Then we could just link all those events to this new stream. An important thing to note here is that those are the very same events, right? So this one is the same as this one and so on. They are just linked to a new, I like to call it new representation of those events, right? So you can look at this as a different information for different purpose. Here, I would just like to see the orders at specific date. But if I would like to make some business decision about basket, I would rather look into this stream, not into the order stream. And every event has its unique identifier, and all events belong to a global stream. So that's why I said it must belong to at least one stream. It's called a global stream. But also it's very useful, and I highly recommend to link events to more specific streams, because later on it's much harder to find the events and make some decision based on that. Each event has the data. So as you saw, the product ID, perhaps the quantity, maybe other stuff. Depending on how you split the product domain, it may or may not have the product name, product price, and so on. But also, it has the metadata, right? So in metadata, I really like to describe, for example, the tenant ID or the client ID. So that's not, to me, that's not very business-specific information, but it's still relevant for this event, for example, for multi-tenancy. So questions that we can ask, or our business can ask, is that who was interested in product X but didn't get it, right? How often do they abandon the basket? And what other products do they buy, and how this fits into this one equation? So basically, we can take a look at daily orders, we can take a look at monthly orders, or however we build our projection, and we can answer, we can just see, different stuff, like what's abandoned, which particular products, because maybe there's a group of clients that just likes to start but doesn't like to finish, or doesn't have money. And then we can optimize based on that. And the question that arises is, event store, so do I need another database? Probably every one of you heard about Event Store DB. Oh, jeez. Some interference, I was saying, I'm holding my hands here. There are relational, there are event stores that run on top of the relational databases, such as we already saw. Rails Event Store that is backed up and maintained by Arkansas. If you happen to work in other programming language than Ruby, is anyone else from outside of the Ruby world? There's also Martin in .NET. There's also something for Python, but I don't remember the name. It's probably Python Event Store. But Rails Event Store, it's already 10 years old, started in 2015. based on the database that you already use. So Postgres users, we got you. MySQL users, we also got you. SQLite users, we also got you. And it's based on two tables. One that contains all the events, and the other one that has events in streams. That's the name of the table, right? So it's basically the table linking your event to how many streams you want. And it also comes with migrations, so it just creates those tables for you. We don't have to do anything. We also cover indexes, and with event browser. And now it would be boring if I didn't tell you a real use case story and what you can actually find by going from snapshot model to event source one. So if you think about the case of a warehouse, right? Warehouse. Stuff comes into the warehouse, it must be checked in, and then there are multiple things happening in the warehouse. You wouldn't imagine how many, but at the end, it just goes out, right? That's what is important. And if you think about one of the smallest possible things in the warehouse, that's a shipment, right? So you may have to, as a warehouse worker, do some packing of shipments, right? You got 5 shipments and you want to pack it into one bigger bundle. So you do the packing. But the thing is that in the warehouse, or basically anywhere in the business, mistakes happen, right? And what information do we have? In snapshot model, we only know that the shipment status is packed. So if we think about billing our clients, they will be billed for packing. Once, always once. But what if we made a mistake? So what if there was a shipment that was first packed and it was supposed to go out, but the carrier said that, sorry, I don't have a place for that. Just bring it back. I'll pick it up tomorrow. It will just go back and the shipment will be changed the status to, I don't know, pending or whatever. And then once again, when it's packed, it will just change the status to be packed. And therefore, once again, we'll only know that we should bill the client once. Even though they made a mistake, they sent us a truck that wasn't big enough to take all the stuff that they keep in the warehouse. So let me show you that on the demo, how this would look like with an event store. So okay. I will start mirroring, yes. Okay, so I prepared a little script. I'll make it a little bit bigger. Can you see it? Okay. So first of all, I defined some events. I'll just go quickly through this. So we have a shipment packed event, shipment unpacked, shipment secured, moved, when you think about moving between different entities of a warehouse, and a checkout. And the way that you can work with the event store is that you can call the publish method, which literally just publishes the event into a stream. I defined the specific one here, which I called shipment $2 because that's the convention. And as I said, the event contains a payload, which consists of the data, which is the shipment ID, in this case, number of pieces that we have packed, and the metadata, which in this case is worker ID. So I also like to care about the context. So I like to know who did the packing and what's the client, right? Who we did the packing for. There is also more information, which I will show you in a second, but you don't have to take care of them by yourself. And of course, in our scenario, we did pack the shipment, right? But then we did unpack the shipment. It's basically the same data. I like to keep the data minimum, right? So if I just packed it and then unpacked, I don't have to keep the information that there was 10 pieces unless I can unwrap it not as a whole, but that's not the case in our example. I can also do some securing of the shipment and then moving it to different warehouses. That's basically the same call to different events. But the essence is that if we pack it again, previously we wouldn't know. We would just see this as a whole process, right? And now I'll show you, if I run the script, then I'll show you how you can see this in the browser. Okay, so let's run the script, and now if I go to localhost, let's do it like this. So in here we can see all the things that happened within the event store, which is enough for us right now as we only publish those 7 events. And as you can see, we start with the packed one. And you can see here the event ID that I mentioned. Each event has the unique identifier, but also you can see when this event happened exactly, right? It's 8:20 in this very evening, so that's why we have this exactly this time. And what you can see here, I'll just zoom it a little bit less. That's the same data that we published in our payload, right? So the data, that's maybe not so super interesting, but there is also the created at and valid at. If I have enough time, I'm happy to talk about the valid at time, what it's supposed to do. But also in the metadata, you can see what we specified, which is client ID, worker ID, but also the event type. This is needed for deserialization, but also for filtering in the event store. But also we have a correlation ID, so we can see which event caused which event, right? So if there is a cascade of events or sequence of events, then we can just correlate all those events within an information, and then we would have this nice navigation link here to see which events were caused by these events. And as I said, automatically, Rails Event Store links your event to additional streams. This one was specified by me, right? I explicitly said this shipment is a shipment that I will identify as shipment 2. But we also have we can filter all the events of a specific type. This is done automatically for you, and also by this correlation ID, which now will be just one event because it didn't cause any other events. And now I'll just show you quickly one other script. So it's pretty much the same, but what I would like to do here is to publish new events and link it to a very similar stream that I showed you on the slides, right? So I would just like to see all the shipments that happened on the 1st of July. So I would use normally this information to build some kind of read model. So if I would like to have a handy access to my events to not read every event from the event store or even from every stream that I know of, I would just have a read model prepared. That would be just an active record model, which then I can quickly query and get the information that I display to the user, right? This way, I can already prepare the data as I publish the events. Okay, so let's run this one. Okay, and now as you can see, we got some more events. But if I go to this event that was just published in the other script, I can see that I can filter all the shipments that were published on the 1st of July, which is a little bit of a lie because this script isn't correctly. I should probably use the less static name here. But you can assume that this demo was first run on the 1st of July. What I could also do, of course, here, I could just put the that probably should also work. So now if we go here, we should have some new events ready to be checked. And this is those are the ones with the correct date, right? So I can just link all the shipments that happened today. This is very useful when you, as I said, when you need to answer some business questions, right? So if somebody comes to you and says, hey, Łukasz, I would like to see all the shipments that were just checked in and checked out today, because I need to prove to our clients that we are fastest in the market, right? Easily. 2 minutes, you're done. You basically got the query. You don't really need to do much about this. You can even just filter. You don't need to write an active record model for that. You can use the Rails Event Store API to just filter the events that you want, and then build your hash, for example, right? Which will just count the number of the events, and therefore you'll have an answer to business. What's the current state for today? And you can take this forward and automate that. All right, I will stop mirroring. Okay, there are some myths that for some reason they are here in the industry for at least 10 years. And yeah, let's just talk about them briefly. So myth number one, you need to learn a new database to do event sourcing. As I told you already, you don't. There are libraries that support event sourcing on top of the databases that you already know. Postgres, MySQL, SQLite, your choice. Whatever you use, you can set up the library and run event store on top of that. Everything has to be asynchronous. No, that's another myth. Nobody stops you from doing everything synchronously, even building read models, building the projections, linking the events. That's your choice. As long as your performance is okay with that, you're free to do so. You don't need to. I like to think about this as taking steps, right? You can take baby steps and first start by learning a new way of storing your data as a sequence of events. And then another step can be utilizing those events and then do something asynchronously, right? You don't have to just take this leap of faith and believe that everything will be fine. You need to learn. Another myth, it is slow. Did you hear about that? That event sourcing is slow? It can be if you mess it up. That's why we need to know about what are our bounded contexts and where our model has the boundaries. You can probably use the domain storytelling for that. You can use the event storming. You can use domain-driven design, or the best combination altogether. But still, if you have entities that don't have really long life cycle, say, I don't know, like 100 or 500 operations happen to an entity, you should be good. So it's not going to be slow. You need to learn about eventual consistency. Yes, but eventually. You don't need this to start off, because eventual consistency is correlated with the thing that everything has to be asynchronous, right? But nobody stops you to have a synchronous subscription. So if you publish an event, you can already create a read model that listens to this event and then updates itself. You can do that. That's pretty legit. And you still get the best of two worlds, because you have a write model that is event-based, so you store every information, so how you got into your current state, not only what is the current state. And you also have a model that you can quickly read, that you can quickly query, that is prepared to be used for your specific user needs. That's a good one. I saw the tweet. I will not mention the guy because I respect him a lot, but he said that there's a myth of every system restart requires rebuilding all the states or the subscriptions. That's obviously not true, because as I said, whenever you have some projection, nobody keeps you from storing it into your active record model. That's what actually I do all the time. Whenever I build some read model, for example, a billing report, I listen to multiple events, and then I build the state, and then when I'm finished building the state, I'm like, okay, persisted, right? Just as you would do with the active record model. But the difference is I know how the calculations were done, which parts of the data were used to actually get this specific number. And refactoring is hard. It's different. I mean, you have to unlearn a few things from the CRUD world, but it is not like, it's probably not the hardest thing that you did. So there are techniques to do that. You can find it all over the place in the internet. But the point is, I think the biggest problem that the people have is that you don't have this update comfort option that you can lean into. So then you think that you cannot cover your mistakes. But what I really like about event sourcing is that we need to stop covering that. So if something happened, it happened. Let's stop pretending that it did not and try to cover that fact. We need to compensate that somehow to get into the correct state, but it's valuable information, especially if we try to fix something and we fuck something else up, right? Then we kind of don't know where we are anymore. But if we see this whole history, then we know at least what we try to do, and we can always take a step back. Another one, it's only for high-scale systems. That's not true. If you find yourself talking with a business people or just having CEO come to your office or call you and say, why is this number, why is this shipment only been charged once, built once? Then you can tell them that, yeah, you can say either I don't know, and if you say if your answer is I don't know too often, then maybe it's a signal that you need to think about a slightly different data model. And you don't need to do that for your entire application. There are, I hope you agree with me that there are the parts of your project, your product, that are super important and that are so important, a little bit less, right? Not everything needs to follow one exactly the same pattern. And my favorite one, it's close to DDD and there's no place for DDD in Rails. That's not true. Some people like to do what Hey and Basecamp do. They use DDD. They implement it differently. I'm not sure if I like this implementation, but what I can say, they do follow the principal rules that are here. We may differ how we implement stuff, but that's how it is in programming, right? Everyone can program it in the way that they like. Okay, so benefits, just to sum it up, because I already told you about them, but the state change history is recorded as a sequence of events, right? So you don't need additional audit table or history table or whatever you use, because you already have that. It's embedded in your model, right? It is here. This is your default way of storing the data. You don't lose any data, any information, right? I think for me, like when there was this AI boom has started, I really like the fact that for some of our clients, we had these event streams that were there for a few years because they could just feed it into LLM and get a lot of information from that. You get auditability. Of course, you don't need it everywhere. That's why I said we need to choose it wherever we feel that this information is valuable, right? Perhaps the history of user last name changes, it's not super interesting. Maybe we don't need to even source that. But the way we work with shipments in warehouse, that's important. And I really like that. Besides the auditability, it's also really good for debugging, because if I find an issue, for example, here, and I can see, even if I work with two models, right, because there is always this transition time, at least the way we implement event sourcing for our clients, there's this moment in time where we actually have the old God class, and we also have the smaller events. And then when I can see that actually somebody tried to secure the shipment in that case, but it didn't do so in some of the billing reports, I can quicker figure out what actually has happened and then spot the error. We can also use that for reconstructing a state, right? So if we need to test some business logic, we can get an entity to exact the state that we want and then try to play our business logic against it. And as I said already, a little bit ahead of myself, it makes the debugging easier because you can actually see what has been happening in the system. One of my favorite things to do, if we have a client with event sourcing already, that's probably the first thing I would do. I would just look like how they have organized the system, if it's around tenants, clients, or whatever. And then I create this linker into which I link all the events by tenant ID. And then I can clearly see what has been happening, what's the history of the tenant. And then, for example, when somebody says that they cancel the subscription and the client doesn't know why, we can just take a look at the data and at least try to guess if there is some nasty bug that just this client is getting annoyed by. For example, double charging for something, right? And that's it. I would like I would like to invite you to check it out at railseventstor.org. And thank you. Any questions? Yes.
I've got a question. So you mentioned that there's no deletes. What if there has to be? For example, you have to be GDPR compliant and you have to delete some user data that you decided to event store. What happened then?
Yeah. So first of all, probably we shouldn't event store them. But if we already made this mistake, then we have few options. Now, if we need to do this exactly in the database, of course, we are still in the relational database world, and we can go into the internals, do some nasty stuff, and violate some rules, but comply to GDPR, which is probably more important than our good feeling about not violating the rules, right? So that's what I would do. But whenever I publish an event and I wonder, okay, what's the information here, right? I usually try to stick to IDs. I almost never, I think I never did the username, last name, email, or whatever. But if I had to, there is this mechanism in Rails Event Store that lets you anonymize this data. So it lets you to encode this data, and then, yeah, I haven't used that. But I know that we have this in documentation, so there is a way to. But you need actually to think ahead. If you didn't do that, then you either need to violate the rules, or depending on how compliant you need to be, right? Perhaps deleting the streams and never having access to them should be enough, or removing the events from your code, but keeping the event store data. I would have to check that actually, but I never run into this problem because I don't publish personal data. That's the reason for that is that we usually start with legacy projects. So my last concern is to event source user data, right? I really don't care about that too much. It doesn't change that frequently. It doesn't really bring that much value to the business. Yes?
I have a question about the event being within many streams.
Mm-hmm.
Of course, I understand the global stream. That's kind of a given. It's just my mindset how you address that. But you've mentioned linking, and as far as I remember, the same thing works for Event Store DB. They have the same idea, and it's quite easy to think about it as a projection because you just project onto a different realm or space. But when I think about an event, it's hard to put my head around an event being in different streams, because kind of an event is something that changes as you've said, the state of an entity.
It represents the state of an entity. Yeah.
Sure. So if you put it in different streams, it kind of you generate like virtual entities which this event changes. Like it's so maybe to arrive at the question, is this something that's, and I know of event sourcing like event stores that don't have this option. So is it something that you came up for Rails Event Store, maybe mimicking Rails Event Store DB, or like how did you arrive to this idea? Maybe like this? Because I can only assume that you were quite close to people who actually implemented that.
Yeah, actually, when I joined Arkansas, or to extend to say, when I converted from .NET to Ruby, Rails Event Store was already in version 2, so I didn't participate in creating the linking feature. But from what I remember from history, and it is inspired by the API of Event Store DB. So that's correct, and that's what mostly why we have this option to be compliant.
Thank you. So maybe I am nitpicky. I
that's good.
Totally affirm that, but I wouldn't call it belonging to many streams, but linked to many streams.
Okay.
But again, it might be nitpicky on my part. But overall,
that's fine.
For the introduction.
That makes more sense to think about linking it instead of belonging. That's correct. Yes, because the way I think about that when I design like some. Sorry, I'll first switch and then I'll be talking. That's way easier to follow. Okay, because the way I think about that is we, of course, should have one class, whether that's decider or aggregate, that should be responsible for saying whether I can check out the shipment or not, right? I would like, ideally, to have one concept in the system that makes this decision. And then, of course, when the event is linked to another stream, another class that is doing something with this event, right? For example, building a read model that is used for creating a report, right? Or just creating a projection. Then I need to keep in mind, like, where this event originates from, right? And that's an important aspect because the projection is just a projection. It's not why the decision has been made, right? So, yeah, that's an important point. And I guess, yeah. So normally, yes. So of course, it requires some discipline to not allow other components to publish the data into your stream, right? So once you introduce an aggregate, for example, if I implemented a shipment aggregate, then if I wanted to do checkout, then if I started publishing events here and there in the application, that's how we sometimes do it, depends on the project, then I would, of course, move all the events publishing into this class. And then I would try to protect my code base against publishing them from somewhere else. Why? Because if this would be my aggregate route, I would like all the if statements, all the rules, all the invariants are fulfilled before publishing an event. Publishing an event meaning transitioning to the next state, right? But yes, it requires discipline, and we haven't. That's like the follow-up question that we often get. Did you develop any way to protect against validating this rule? No, code review is sufficient for now, and the clients quite quickly get how they need to work with events because, as I said, it's not that hard, right? If you have one model that is responsible for the decision, and then you shouldn't manually try to infect anything, pollute this model from the outside, pollute the data of this model from the outside. But of course, we can automate this, right, if we want to, or create some protection against these mistakes. Any other questions? All right, then thank you.